Okay, so welcome to question 2. This is part 2. So here we are talking about block ciphers. So question 2 reads, you receive a message that was encoded using a block encoding scheme with the encoding matrix, which is this, and the decoding matrix, which is this. So decode the cipher text XOR Operation, which is being decoded with this. So since it's a block cipher, not a stream cipher, we can decode by putting these in blocks. So for example, I can decode mx first using this decoding matrix. So m is represented by number 13 on the alphabet. Then q, as we can see, x is represented by 24 on the alphabet. Then our decoding matrix, as you can see, is that. So that's the decoding matrix. Then now since we have that, we know that matrices work by row by column, row by column. So the first thing we'll do is 13 times 5, so row by column. Then you say plus 24 times 19, then you leave a space. Again you start 13 times 24 because it's row by column, then plus 24 times 3. Now here I'll use a calculator on my phone. So 13 times 5 was the answer. So 13 times 5 we get 65. So I'll say 65, then plus we have 24 times 19. So we have 456. 456. Then we leave a space. We have 13 times 24, which is 312. 312. Then plus 24 times 3, which is 72. Okay, now we can say 65 plus 456, which is 521. Then we leave a space. We have 312 plus 72, which is 384. So now that we have done finding the matrix for this, you can see that our alphabet ends at 26 and these numbers are too big. So we need to find the modulars for this, or to wrap them around. So what we do is that we have 521. We will say divide by 26 for us to find the modulars. So 521 divided by 26. So we have 20.0, then 03. Okay, so I'll get this 20 but without the 0.03, then multiply it by 26. Then after doing that, I'm getting 520. So the first number we had from this was 521. So I'll say 521 minus the new answer I have, which is 520, for me to get 1. So now on the alphabet, what is 1? So it's A. So this whole answer represents A. Now that we know that decoding M will give us A, I will just go where this question is, then where there's M, I'll put A. So we have started decoding it now. Okay, so let's now convert this or wrap around 384. So remember, again we'll say 384, that number we have, divide by 26 for the alphabet. So we get 14.7. 14.7. Then I'll say 14 without a point, then times 26 for the alphabet. So it's giving us 364. So 364 like that. Then I'll say that number we had, which is 384, minus this new answer we have, which is 364. Then what's the, so we are getting 20. So now what's 20 on the alphabet? So 20 on the alphabet, as you can see, it's T. So here we have T. So if it's T, we can go on our plain text and add T where there's X, because X now has turned into a T. So we have decrypted those two letters as a block. So now let's try to decrypt these four letters at once, because it's a block cipher. We can decide how many letters we want. So let's do that. Okay, so this is how you arrange the order. Since we had O S H I, so the order will be O S H I like that, and our decrypting matrix. So remember, again, it's row by column. So we need to find out what is the position for O. So for O, as we can see here, it's represented by 15. So we'll say 15, then a space. S is represented by 19. So 19, then H is represented by 8. Then a space, I is represented by 9. Then once we are done with that, we can now write our decoding matrix. Okay, so it's row by column. So this is our row and this is our column like that. So first thing it will be 15 times 5. Then you say plus, we have 19 times 19, row by column. Then you leave a space. So again we have 15 times 24, just like we did for the first one. Then we say plus, now we have 19 times 3. You are done for that one. Now for this one, we'll be saying 8. So we are now row by column like that. So it's 8 times 5. Then you say plus 9 times 19. You leave a space. We have 8 times 24. Then plus 9 times 3. Like that, we are done. Now we start calculating. So 15 times 5. So we get 75. Then we say plus, we have 19 times 19. So we get 361. Then leave a space. So we have 15 times 24, which is 360. Then plus, we have 19 times 3, which is 57. Okay, so we close. Then at the bottom we have 8 times 5, which is 40. Then plus, we have 9 times 19, which is 171. Then space. So again we have 8 times 24. So we have 192. Then plus 9 times 3, which is 27. Okay, so now we can start adding. So 75 plus 361. So we have 436. Then we leave a space. 360 plus 70 what? 360 plus 57. Okay, so that's 417. We close. Then 40 plus 40 plus 171. We have 211. Leave a space. 192 plus 27. 219. Okay, so we are done with the matrix, but again these numbers 1 2 3 4 exceed 26, so again we need to find their modulars. So we start with this, which is 436, then we divide it by 26, so we get 16.7. then we get that 16 without a point, then we say times 26, so we get 416. Then the whole number was 436, so we say 436 minus this new answer, which is 416, so we are getting 20. So remember, on the alphabet 20 is T, so for this one it's T. So again we go back to our plain text, then where there is O we put T like that. So now we just need to continue the modular, so the wrapping around for those three last numbers. So we'll do the same thing. So here we have 417 now. So remember the way we are following the order. So we have 417, we need to say divide by 26. So we get 16.0, 16.03. Then here we'll just get 16 without the 0.03, then we say times 26. So we know that we are getting 416 because this is a repetition, 416. Then the whole number for this one, as we can see, it's 417 minus this new answer, which is 416. So here we are getting 1, and on the alphabet 1 is just A. So here we say A. Then we'll go back to our plain text, the one we are creating, then here we put A. Then we are remaining with 2 letters or 2 blocks, so to say. So let's just continue doing the wrapping around or the modulars for these. Okay, so let me go down and we continue. I don't know what's wrong with my cursor. Okay, so here now we are at 211. So I'll say 211 divided by 26. So here we get 8.1. Okay, so we'll say 8 without a point, then times 26. So because our alphabet is ending at 26, so 8 times 26, we get 208. So the whole number, which is 211 minus 208, our new answer, we are getting 3. On the alphabet, 3 is represented by C. Okay. So I'll go on my plain text again, then add a C. So we are remaining with the last one. So here, as you can see, we have 219 to represent the last one. So 219, we'll say divide by 26. Then what's the answer now? So 8.4. 8.4. Then I'll get that 8 without a 0.4. Then say 8 by 26 for the alphabet to get 208. Then we'll say the whole number, which is 219 minus the new answer 208 for us to get for us to get 11. So on the alphabet, 11 is K. So I'll show you. So 11 is K. So we need to put K on our plain text. So to show that 11 is K, here you can see that 11 is K. So on our plain text, I'll put K. So we are done decoding this message using this matrix as a block cipher. So now you can see that attack can be represented as this when encrypted. So we have decoded this and we were being attacked. So that's it for the block cipher so far. So the question continues that prove that M times M is equals to this identity or unit matrix 1 0 0 1. Okay, so here is just a matter of you knowing how to deal with these matrices. So let's do that. Okay, so we are trying to prove that if we multiply these two, which is this, we'll get this. So let's do that. So row by column, row by column, row by column, row by column. That's the rule. So we'll start. So as we can see, our first row, which has 3, will be multiplied by the column which has 5. Then we say plus the row of 2 times the column of 19. We give a space. The row of 3 times the column of 24 plus the row of 2 times the column of 3. Then we close. Now we go down, we do the same. So we say 7 times 5, then plus 5 times 19, we leave a space. 7 times 24 plus 5 times 3. So just like that we are done. So now we just involve the calculator here. 3 times 5, which is 15, plus 2 times 19, which is 38. Then a space. 3 times 24, which is 72. Then plus 2 times 3, which is 6. Then you close. Now we have 7 times 5, which is 35. Then plus we have 5 times 19, which is 95. Leave a space. 7 times 24, which is 168. Then plus 5 times 3, which is 15. Then we close just like that. Okay, so now we add 15 plus 38. So we have 53. Leave a space. Then we have 72 plus 6, which is 78. We close. Then we have 35 plus 95, which is 130. Space. Then we have 168 plus 15, which is 183. Then we close like that. Okay, so now we are done with the matrix. So we need to do is to wrap around. So wrapping around 53, you just say 53 divide by 26 for the alphabet, which is 2.03. So I'll get 2 without a 0.03, then times 26 for the alphabet, so which is 52. So you get 52. Then the whole number, as you can remember, the whole number is 53. So minus 52, we get 1. So for this one we are done. We have proved that here we have 1. So here we are done with the 1. We come to this corner to prove that it's a 0. So at this corner, as you can see, we are having 78. So we'll say 78 divided by 26 for the alphabet. So it's a direct answer, which is just 3. So now we get that 3, then we say 3 times 78, which is giving us 3 times 26, which is giving us 78. Then we get 78, the whole number. We say 78 minus this new answer, which is 78, for us to get a 0. So you have proved that we have a 0, which is okay. So we go down here to prove that again it's a 0. So using 130. So we have 130 divided by 26. Then as you can see, 130 divided by 26, we are getting 5. Okay, so we'll get that 5, then times 26, then it will give us 130 again. So that one number, which is 130, minus the new answer, which is 130 again, we are getting a 0. So again, we have proved that, okay, this is a 0. So now we are coming to prove that it's a 1 by using 183. So there now we have 183. Then we say divide by 26, what's the answer? So we are getting 7.03. 7.03. Then we'll get that 7 without a 0.03. Then we say times 26 for the alphabet, which is 182. Okay, then we have the whole number, which is 183, minus our new answer, which is 182. Then we are getting 1. So we have officially proved that also this is a 1. So it can be represented as a matrix now as 1. Then here we have a 0. Then down we have a 0 again, and the 1. So we have proved. That's it. Okay, so B. Okay, so the DES algorithm combines 2-bit strings applying XOR operator on each of corresponding bits. Compute the 6-bit string that results from this. So since we are having 1 0 0 1 1, then another 1, so what we need to do is to write another one, which is 1 1 0 1 0 1, like that. So for this one, you need to know how to convert to binary. So here is what you need to do. For this row, we have 1 plus 1. So 1 plus 1, the normal answer, as we know, it's 2. So if the answer is 2, if we convert it to base 2, then the answer, which is 2, we want to know the remainder. This is what we need to do. So quite alright, it's going to base 2. Then 2 divided by 2, we know it's 1. Then the remainder is 0. So for this, we can say here we have a 0, where we have that 1 and the 1 here to be a 0. Then we have this other one, which is 1 plus 0, 1 plus 0, and we are getting a 1. Then to convert it into base 2, we have base 2 itself, then a 1, and the remainder. Okay, so now base 2, it will repeat as base 2, but 2 into 1, it's a 0, remainder 1. So here we'll get a 1. So here we are just putting the remainders. You get a 1 like that. So you put a 1 there. Okay, then in conclusion, we can say that same numbers or same bits will be getting a 0. then different bits or different numbers will be getting a 1. So since 1 and the 1 are the same, we will get a 0 like that. So let me just remove this, then put everything in order. Okay, so we have 1 and the 1, we know same, it's 0. Then 0 and the 1 different, it's a 1. Then we have 0 and 0, so same is a 0. Then 1 and the 1, same again, it's a 0. 1 and the 0, so different, it's a 1. 1 and the 1 is a 0. So as we can see, we have concluded that different same numbers or same bits, we are getting a 0. Different bits, we are getting a 1. Same bits, a 0. Same bits, a 0. Then different bits, a 1. Same bits, a 0. So that was the answer. So we are done with question 2. So this is Soko James representing KMU Cybersecurity Tutorials as a tutor. So part 3, we will cover question 3. Thank you.